Hi folks, Eldon Yoder here with Yoder Outdoor Furnaces. Thought I'd explain how a pump or a circulator works. Some people refer to it as a pump, and that's fine. Other people would say that it's a circulator because it's circulating water. It's moving water around a loop back to a tank or reservoir or whatever on the stove, not like a well pump that's just deadlifting the water out and it doesn't return. So these are small. Typical outdoor furnace pumps are pretty small. That's a big 0011 Taco. Some Wheelo pumps, different sizes. That's a 009 Taco, is a high pressure but lower flow. There's different sizes here. This is probably the most common one I use. It's a Grundfos 1558. It's a 3-speed. Around here. All your pumps would have numbers there on the end. If you see on the Type 1558 FC, that's a flow check that I usually remove. That's your model number and the brand, and if you look them up you can see what kind of output. You can see the different amp ratings and such. They're very low amp draw. But the way these pumps work, this one's probably like about a 20th of a horsepower or something. I don't know if it says on there, but for years I didn't understand how it works, but if you actually look on the end of the pump here, it's fairly easy to see. This is where it goes in. It uses a rubber O-ring to seal up against the pump flange. All pumps bolt up the same. You can see in the casting here, so the water, you back up, water comes in here. There's suction here when the impeller is spinning. There's a wheel there, I'll show you in a minute. Comes in and goes into the center of the wheel, and if you can imagine a round wheel with a hole in the center and like little paddles, and it's spinning at a pretty high RPM, and as the water comes around that's trapped in those little paddles or veins, it throws it out this end here. I'll show you that. You can see the direction of flow, that arrow. All pumps or circulators will have an arrow direction of flow somewhere on the pump. So if you get on the end here, I can turn this pump on end, it'll stay here. If I shine a light down here in the outlet, it's bright, there. You can see the little wheel there inside, that little white wheel. It's a plastic wheel. It's got veins in it. And again, like I said, the water sucks in here in the center, and it throws it out this end here. So interestingly, if you're, let me back up here. So it's throwing it out the end. The pressure's probably not more than a couple PSI. So if you got air in your loop, it's not going to circulate. That's why it's important to purge the air with like house pressure or something to blow it all out before you try to circulate, unless it's just a really short loop. But a lot of people think their pumps aren't big enough, and the reality is they haven't purged the loop properly. This one is a 3-speed. I would often run it on high speed unless it's a really short loop. But, you can do it down to medium or low, and that gets into how you design your system, and each situation is a little different. But this is a pretty standard pump that I would use up to, on a 1-inch line, up to maybe 125 feet, and 3/4 inch loop if it's a shorter loop. I mean a 3/4 inch loop to like an air handler inside a house, maybe up to 70 feet or so one way. Again, it varies depending on what I'm trying to do with it. But now this one here has kind of a medium pressure, medium flow. You can also get higher pressure pumps. So this is a Wheelo, excuse me, I'm in the wrong one here. This is a Wheelo. You see the direction of flow. It's a pretty high pressure. It'll deadlift about 32 feet. The Grundfos will deadlift about 18 feet. So to get that higher pressure, you can see the diameter of the wheel, the casting, is much larger. So it's going to have a lot more velocity. The speed that it's moving at the same RPM is the speed as it comes by here is higher. If you look at the outlet, you're like, whoa, that's small. This is a fairly low flow, but high pressure. So it's not trying to move a lot of water, it's just getting a lot of pressure behind it. This is good on like smaller 3/4 inch piping. That's a longer run, like say 100 feet plus, where that one wouldn't put out enough flow. The same thing here you see on the intake, very small hole. It's not moving a lot of water, just putting a lot of pressure behind it. If you look on this Taco, same thing. This is equivalent in a Taco brand. Small casting, small hole, big wheel, narrow diameter. It's not trying to bite a lot of water, just move it fast in the spinning mode. And there's your outlet side. If you can see, get my angle right, if you can see the wheel, it's a very narrow and tall wheel. Good for high pressure, but not a lot of flow. There you can see it. If you get into a higher flow situation, larger piping, but you still need some pressure too, it's a longer run, like this is a 0011 Taco. And now we have a much larger intake. There you can see the groove for the O-ring. Direction of flow, there's the arrow. The wheel diameter is fairly large. It's not quite as big as some of those high pressure ones that I was showing you. And here's your output side on this one. Let me see if instead of using a flashlight, I can turn it towards the light. It's hard to hold this and do everything at the same time. There we go. On this one, the wheel is it's somewhat wider and a fairly large diameter. It can bite more water. So all these things, I mean, obviously I'm not an engineer, but they build them different shapes and sizes for a reason. But you can, if you know what you're looking at, you can look at a pump and see if it's a high flow or a low flow, and a lot of that just by looking at the casting on the end of it. But it's just a wheel spinning, throwing water out the end. If you can imagine tying a weight on the end of a string and spinning it around your head and letting go and letting the, if you tie a bolt or a fitting or something on a string and just spin it and let it go, that's what it's doing to the water, just giving it a fling down the pipe. But it's very small wheel, and so yeah, you get some air bubbles in a hump and it'll just lock it up. But something like this one, or especially these high pressure like the 009, will push air bubbles through easier at the cost of a much higher amp draw. So instead of being 3/4 an amp like that Grundfos there, you're looking at 1.4 amps, which is still not a lot. The 0011 Taco is 1.76 amps. So yeah, you can put a bigger pump on, but then you're paying for more electric the rest of your life, or the life of the pump. So I kind of try to use some common sense and don't overkill it. But anyway, just thought I'd share a few things here, how pumps are made. If you ever get a chance, you can take these pumps apart. There's little Allen screws there. There's 4 of them, and if you take that loose, there's an O-ring at the seam there where it goes together, and you can actually pull it out and see the whole rotor, the whole wheel there, sticking out of the motor. So yeah, there's not much to them. Just a casting on the end, a motor, and a little wheel, and it gets the water where it needs to go. Hope you find this interesting. Thanks for watching.